Hello guys, Jagveer Singh back with another video. In this video, I will show you and explain what does differentiation means. So let's get started. So by definition, differentiation means rate of change of a function with respect to the input, or in general is x, and is denoted by dy by dx, where y is some function and is changing with respect to x. But when you think about it, what does actually means? Then you go ahead and try to understand it. Okay, are we talking about a function? So what is a function, and what is derivative, what is derivation, what is integration later on, which we will cover up. But it's a basic concept which starts with a lot of questions, and if the basic is not clear, then it will continue throughout. So I'm just going to give you two examples. One is just a simple example which everyone go through, and that is life. And the second one, I'm going to show you the rate of change of area of a square or a cube or whatever you can say. So if I start with differentiation, so let's take an example of a function that we are all familiar with, and that is life. So let's say this is y-axis and this is x-axis. So these are two axes that I drew. On the y-axis, I'm just going to say that, okay, I'm just going to denote y-axis to be the problems that we face in our life. So now everyone have some kind of problems in their life, and the x-axis is going to be our time in terms of years, the number of years that we spent on this earth. So we started from zero someday. So like I was born in year 2000, so it's going to be 2000, and now I'm like 24 years old. So, and it's 2024 right now. So I'm just going to denote it this way. So if I draw a graph of my life which represent the number of problems that I had. So when we grew up, we don't have a lot of problems because our parents are there to solve those problems. So let's say I started with few problems, almost zero problem. Then with time, the problems start increasing. Then we start facing more problems, but then we also understand how to solve them. So it started decreasing. Again, it started increasing. We have a lot of challenges that we overcome, a lot of failures, and then we start succeeding as well. So the problems start declining, and let's say right now we are facing few problems, or I'm facing few problems in my life. So that is a function that we can say of problems with respect to the time or the life that I lived throughout the 24 years. But it wasn't like this, that I was born and I went to 24 years just in one shot. I went through 1 year old, 2 year old, 3 years old, and so on, all the way to 24 year old. If I just make 4, 5, 6, 7 for a better understanding, and like all the way to 24. So let's say, now you might be confused that what does that have to do with differentiation? If we are just talking about differentiation in general. Differentiation is that we are trying to find an instantaneous point and trying to find what was the number of problems that we had at that particular point. So let's say if I point out how many problems I had. So let's say these are the number of problems that I faced in my life. So let's say this is 1, 2, 3, 4, 5, 6, and so on, right? So we can say that I'm more interested to know that when I was 5 years old, how many problems did I have? So when I was 5 years old, if I drew a vertical line straight up, I find that the function is intersecting at this particular point, and if I draw a horizontal line, I can say that almost in between like 3 to 4 problems, those were the number of problems that I was facing during that period of time. Similarly, if I say that when I was 7 years old, I was facing slightly more problems, and those were around like 4 to 5 years, or like 4 to 5 problems in that particular year. But if you think about it, I'm talking about 5 years, that is 365 days, right? So does that mean that when I was 5 years and 1 month, or when I was 5 years and 2 months I had the same number of problems. Well, that's kind of the root that we are trying to find using differentiation, because that's where differentiation come into existence, that we are trying to make an analysis of a very small change, of a very finite change. So like at 5 years old, so let's say if I zoom in to this particular point, so it might appear as, so let's say this is the zoom in of this small point, and it's going to appear something like this. So when I was, let's say, 5 years and 1 month, I had, like, let's say, almost 2 problems, whereas when I was 5 years and 2 months, I had 2.5 problems, let's say. So, but we need to zoom in. What we actually did is we analyzed that particular situation for that particular graph. And we can also see it's changing continuously. Sometimes the problems are increasing, sometimes if I solve more problems in my life, it's decreasing, and again increasing if I'm not able to. So similarly, this is in layman terms the understanding of differentiation, so that it's easier for you to understand what differentiation is. And now we will take a more practical example, that is by taking the area of, let's say, in this we can take any quadrilateral, but I'm going to just go for square because it's relatively easier to understand. If any one of us who have some basic understanding of differentiation, or we have studied somewhere in high school or in secondary school as well, we know that differentiation is represented as dy by dx, which is the rate of change, which is dy or delta y by delta x, which is rate of change with respect to x, which is the function in terms of the input. So let's say if we have this particular graph and we have this some random function, this is x-axis, this is y-axis, something similar to what I just explained in terms of life. So it's changing continuously. So this is a slope where it's changing again, it's not changing that much, and here it's changing again way too much. So it's dy by dx, you can say that, okay, is equal to the slope. So this is the basic understanding, just to familiarize before I start into the concept of differentiation. So now if any one of us who have studied about area, and so let's say if I talk about a square whose one side is x, so the other side is also going to be x because it's a square, and we also know that area of square is x square or side square. In this case we have x, so the area is going to be x square. Also, if you have studied differentiation before, you will also know that if I take the derivative of this area, or d by dx of area, it will be equal to 2x using power rule. But we will explain later on. This is just an example. But how do we know that this is correct? That if we take the derivative, it will be equal to 2x. If we take the derivative of this entire area, then it is going to be 2x. And what does that actually means? What does that means is, so let's say if I change this particular area, right now I'm just taking example of area to be equal to x square. So let's say that instead of this particular square, which is x by x or x square as an area, I take another square which is slightly bigger than this, but very small change in x. So let's say this is x, and I just increase it by a very small amount. Let's say this is delta x, and this is again x, and this is again x, right? A very small change. I just increase the entire area by a very small minute change, which is delta x by delta x. So now, because we can make a graph out of it when we have area equal to x square, so I'm just going to make it into two separate side by side comparison. It's going to be easier. So when area is x square, So let's say for at x equals to 2, 3 and 4. Let's say these three examples. So I can just make a small graph kind of a thing. So let's say at x, I'm going to denote area by a capital A. At x equals to 2, we will have x square, which is going to be 2 square, which is going to be 4 in terms of area. Similarly, when you have x equals to 3, you will have area to be 3 square, which is going to be 9. Similarly, when you have 4, it's going to be 16 and so on. So now, because we increased the area by a very small portion, so the x, instead of, let's say for 2, I'm just going to take as at x equals to a very small change, which is going to be 2 point, let's say 0.0001, a very small change in x. What's going to be the new value of the area? Because we know that area is x square, so area is going to be x square. If I just quickly use a calculator to make sure what the value is going to be, it's going to be around 4 point something 0004, 0001 square, and the area is 4.00040001, right? So now we have at x equals to 2.0001, we have area to be 4.0004 point something something. So it's almost close to 2 and the area is almost close to 4, but it's not exactly 2 and 4 respectively. So what we can say is, so this is after the change, this is before the change. So like if I just take one particular coordinate at x equals to 2, we have the area equals to 4, right? And similarly at x equal to 2.0001, we have area equal to 4.0001. So we know that differentiation is rate of change of y divided by rate of change of x. We can confirm whether we are going to get the differentiation of the area to be equal to 2x that we did initially. So we are just going to confirm. We have x equal to 2 and x equal to 2.0001. So the delta x is going to be 2.0001 minus 2. Similarly, we have delta y equals to 4.00040001 minus 4. In this case, we have 0.0001 after subtracting, and we have 0.00040001 or 0001, right? So now, as we know that differentiation is dy by dx, we can confirm it. Let's see. We have dy by dx, which is the derivative, should be equal to change in y with respect to change in x, which is 0.00040001 divided by 0.0001. So if I do the maths, you can see that if I divide it by 0.0001, it's more or less very close to, if you think about it, it's very close to, it's almost 4 if I divide both of them, and we get the derivative at x equals to 2 to be equal to 4. So now if we come back to this particular problem right here, if we take, because we have taken x equals to 2, if we input that value, then we get area equals to 4, or the derivative d by dx of area at x equals to 2 is going to be 2x, which is 2 times 2 equals to 4. So as we can see, even if we use derivative directly, we are getting 4 as the answer, whereas if we take by reasoning, like what actually differentiation means, is basically a minute change in terms of area by a small value called delta x, similarly, which will have an impact on y as well, because y is the output and x is the input. If we are changing the area by a small amount, then obviously the output, which is the y, is also going to change respectively. Similarly, if we take an example at x equals to 2 and a very small change to be 0.0001, we are going to have a different area that is going to be delta y, 0.0004 something something, and when we divide both of them, the rate of change is going to be 4, which explains that okay, this is how differentiation works. When you are going to compare two values that are very close to each other, eventually you can say is differentiation is kind of finding a formula for solving or trying to find a relationship between two very close function inputs. So like in this case, we have at x equal to 2 as an input, and the other input is x equal to 2.0001, which are very close on a timeline. If I draw a graph, something like x and y is going to be very, very close. So like 2 is somewhere here and 2.00 is right next to it on the right hand side. So this is going to be 2.0001. And if we draw a graph, then obviously we won't be able to see a massive difference between these two. But we are able to derive a formula based on it using differentiation. And so this is what differentiation is and how we use it. So I hope you understood the example with both the life experience that I showed initially with the life problems to just get a feel of what differentiation is, and then a practical experience with the rate of change of the area of the square that I just showed, and also proved eventually that they are the same, that even if we apply the formula for differentiation, the derivative of the area is 2x, and if we take at x equals to 2, we are getting the derivative to be equal to 4, and similarly we just proved it using the actual example with a small change of 0.0001 as well. I hope you like it, and in upcoming videos I will start with solving problems that are related to differentiation, and then later on integration as well. So stay tuned, and I hope you like this video and subscribe if you like. Thank you.